In the last module, we've had a look at Rutherford's Goldfoil experiment, and in that experiment, Rutherford found out that a thin gold foil was able to deflect heavy alpha particles by almost around 180 degrees. So now Rutherford concluded that Thomson's plum pudding model was wrong, because according to it, the gold foil should not be able to deflect any alpha particle by 180 degrees, right? So clearly the Thomson's plum pudding model was wrong. Now Rutherford had to come up with his own model to explain the results of the gold foil experiment. So now let us have a look at the model presented by Rutherford that could explain the results of the gold foil experiment. So firstly, here I have an aluminium foil. So imagine this aluminium foil as the gold atom. So this is one complete atom here. Imagine this as the atom. And according to Thomson's model, the whole mass of this atom is evenly spread out in the whole atom, right? So now imagine this is the atom and I have a stone which is the alpha particle. If I throw the stone at this aluminum foil, it would clearly make a hole and pass through it, right? And that is what was expected based on Thomson's model, right? Based upon Thomson's model, yeah. But Rutherford had obviously clearly observed that the gold foil was able to stop and deflect the heavy alpha particle. So now if I have to deflect a stone using this aluminum foil, how do I do that? Well, obviously this spread out mass cannot deflect a stone. So for this to be able to deflect a stone, the whole mass should be concentrated in a very small place, right? So what Rutherford said that instead of having the whole mass spread out like this, because such a mass cannot deflect any alpha particle, we can have the whole mass concentrated in this very small space. And now if I do this, now if I throw a stone at this, the stone will be deflected very easily. So this is what Rutherford came up with. He said that the whole mass is not spread out in the whole atom, but the whole mass of an atom is concentrated in a very small tiny place. And he called such a small tiny little place where all the mass of the atom is concentrated, he called it the nucleus of that atom. So the nucleus of the atom is this tiny little space where all the mass of that atom is concentrated. Now the question that arose, was asked to Rutherford by other people around him. So they asked him that, so the atom is this big and all the mass is concentrated in this very small place. So what is in this whole area, in a whole volume around the nucleus? And secondly, scientists around that time made some calculations based upon quantum mechanics and all that. I don't have a really good idea of what those calculations were, and so they were very complex and I don't think they should be included here. But the basic idea was, so remember there was this experiment that figured out that the atom had these tiny electrons. Now where do we put those electrons? Are those electrons inside the nucleus or are they somewhere else? So they did some calculations and predicted that these electrons cannot be present inside this nucleus with the whole positive charge also, because remember we have these electrons and we also have some positive matter so that the whole atom as a whole is neutral or has zero charge. So obviously these electrons cannot be, so they predicted that these electrons cannot be present in the nucleus. So what is left inside the nucleus? So now Rutherford had to say that the nucleus has only the positive charge inside it and the electrons are not present inside the nucleus. He said that these electrons are actually present around this nucleus in this outer remaining area, in this remaining volume. But obviously if these electrons are stationary like this, the positive charge would actually attract these negative charges. Remember, opposite charges attract, and these electrons would then have to collide, would then slowly move together towards this positive charge, and then it would again be attached to the nucleus. So obviously these cannot remain stationary. So what Rutherford did, he said that they are not stationary here. So what happens is, according to Rutherford, he said that, so this is the nucleus here in the center, and these electrons actually revolve around this nucleus. So let's say this is one electron revolving, here's another electron revolving. So he said that these electrons keep on revolving around this nucleus, and this is similar to our solar system. So this is like the sun, the nucleus is like the sun, and the electrons are like the planets, and they keep on revolving around this nucleus, and that is how, just like the planets stay in this stable orbit around the sun, similarly these electrons stay in this orbit around the nucleus. So that was the model proposed by Mr. Rutherford, and because this resembles our planetary system, our solar system, this is also called the planetary model of the atom. And so I hope you've seen such pictures, right? You've seen such pictures where you have a large nucleus in the center and we have the electrons revolving around it. So this is a basic idea that was proposed by Mr. Rutherford, and this is Rutherford's model, or the planetary model, where all the mass, which is essentially the positively charged matter inside the atom, which is concentrated in this tiny nucleus here, and the electrons, the negatively charged electrons, they revolve around the nucleus in such orbits, circular orbits. So that was Rutherford's model. And yeah, that's it for this video.